Alright guys, so let's go ahead and take a look at number 10 now. So number 10 looks a little bit simpler, but so we got y equals square root of x and y equals 6 minus x. We can do the same thing we did like for number 6. We can say, they're both equal to y, so I can write this as square root of x equals 6 minus x. But now what do? This is kind of a new situation. We haven't really been here before. And I'll tell you, this is what we can do. We have square root of x. I don't want square root of x. I want x. So what we can do is we can square both sides. I can square this, and I can square this. Now what ends up happening is square root of x squared, the square root and the squared kind of cancel out, and we just get x. And then over here, we get 6 minus x squared. Now we got to remember, go off to the side, that's like saying 6 minus x times 6 minus x. Now, we get to FOIL this thing out, so here, 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 and here. What ends up happening is we get 36, 6 minus 6 times a minus x, and then minus x times 6. We get 36 minus 6x minus 6x plus x squared. We can combine the like terms in the middle, and then so we get minus 12x and then the plus x squared. So that's what ends up happening right there. Alright. So we get this stuff here now. Now we have another quadratic. We can go ahead and just solve this one for x. So let's get the x over to this side. So we get 0 equals, I'm going to rearrange this so it's the squared part first. So x squared, we're subtracting an x from both sides. So it'll be minus, what's that, 13? Minus 13x plus 36. And now we got to factor this thing. So we get x minus 13 and plus 36. What's that? Minus 9 minus 4. So minus 9 minus 4. So let's see what happens. We say x minus 9 equals 0. X minus 4 equals 0. Just like we've done before. Solve both these for x. So we get x is 9. And x is 4. So those are, again, we have 2 points, and these are x values for those 2 points. So let's go over here and see what's going on. So we get x equals 9 and x equals 4. So let's plug both of these values in, and we will see what happens. Let me do we'll do 9 first, it's fine. So let's plug it in. We'll plug it into, let's use the second one here. So y equals 6 minus x. So if we use y equals 6 minus x. Y equals 6 minus x. Okay, we plug in 9, so we get y equals 6 minus 9. And hang on 1 second, guys. Sorry about that, guys. So we get y equals 6 minus 9, and so y equals a negative 3. So we get the point 9, negative 3. And then over here we plug in the 4, so we get y equals 6 minus 4, so we get y equals 2. So we get the point 4, 2. Now here's the thing. If we go back and look at our 2 equations we had, this one's a square root and this one looks like it's a line. This negative 3 we got for an answer when we plugged in 9 should throw up a red flag. And we should not get a solution that's negative when we do the square root thing. We're not really allowed to have that. And if we take a look at the graph, let's take a look at the graph of this thing. So we got y equals square root of x, y equals 6 minus x. So if we look at the graph of this real fast, square root of x looks like this. And 6 minus x, that would be like something like this. Something like that. All right. So it looks like we should only have 1 point. That 1 point right there is where they cross. And that looks kind of like pretty close to our 4-2. Pretty close to our 4-2 or something like that. So where did this 9 negative 3 come from? 9 negative 3, that looks like it would be down here somewhere. Over 9 down 3, so over here someplace. And what ended up happening was, over here when we squared it, to go from square root of x to just x, when we squared it, we picked up an extra solution. And what we ended up doing was, instead of graphing just this half of it, we ended up graphing this whole like sideways parabola looking thing. Alright? So that 9 minus 3 is this point down here. Okay, so this is kind of a weird situation. This doesn't always happen, but whenever we have to do something like this, like square everything, that ends up it could create extraneous, what they're called extraneous solutions that make it work when you do the math, but when you go back to the original equations, it doesn't really make sense. So a nice thing to do is to just kind of look at the graph of these real fast and see if anything makes sense. This is like the only time that this ends up happening, but I just want to kind of show us that it can happen and it's kind of a weird thing. So again, what ended up happening was when we squared it, we ended up kind of changing the equation a little bit. We changed this one at least, because in the square root of x, essentially what happened is we changed the domain. Because the domain of square root of x, you can't have negatives. If you just have x, well, x can be negative if it wants to. There's no rules against that. So that's what ends up happening. When we went from square root of x to x, we made it so here you can't use negatives. Here you can use negatives. And since you can use negatives, we kind of added in that bottom half of this thing. And so we kind of now have a new point where it could have worked. But this part of the equation doesn't exist. So this solution doesn't work. Okay? We should only have that one solution that's from the original equations. That's kind of a unique situation, doesn't happen too often, but I just want to kind of show us and see what's up. So if the finished product would be this one, didn't count, so we just have one point where they cross, the point 4, 2, which is right there. All right? Good deal.